Yes, this is a really good question because now you're zooming in on the boundary between React DOM and CSS. First, can React work without import create root from react-dom/client? For a web browser React app, not really in the normal way. So if you're using a React in a web browser, not in a mobile application, you cannot really do that without React_DOM/client in the index.html bootstrapper we discussed in the previous video, because React by itself knows how to create React elements, run components, manage state or hooks. React DOM is the package that knows how to talk to the browser DOM. So without React DOM, React can still do the JavaScript description part, but it has no browser renderer attached. Think of it like this: React equal what UI should exist. React DOM how to put that UI into the browser. So if you remove create root ... React does not automatically get some secret built-in DOM access. So think about this like this. The React again is what the UI instruction would look like. So those are compiled already, including the state updates that need to update the actual DOM. But for it to be able to project that into the browser, you will need this create root specifically from main.jsx. So these create root are actually a methods exported by react-dom/client. It needs a renderer. For the browser, that renderer is react-dom. For React Native, it's a different renderer. For testing, there are other renderers. So React Native, that's for mobile application. For testing as well, they have different renderers. So React Core is renderer agnostic. Can you use React without create root specifically? Yes, but only in special cases. Old way before React 18, people use import React DOM from React_DOM. Here, React DOM that renderer with a argument app element, comma document that get element by ID, parameter string root. That still used React DOM, just an older API. So before, we can get away with not using create root and using this React DOM.render with using this pattern React DOM.render, first argument app component, comma document that get element by ID root. So notice we're still bootstrapping the root in index.html. Now that still use React DOM, just an older API for React, or just an older API of React for contacting DOM. Another way, you can also use React without rendering the DOM at all. For example, function app empty parameter, then inside return h1 element with the string hello inside, then closing of function and console.log parameter app function empty parameter. So here in this function, we use React, but we did not actually change the DOM. So it's just a plain JS running on V8 engines. So that worked as plain JS and produces React element objects, but nothing appears on screen because no DOM renderer is involved. So React can exist without create root, but a browser app still needs some form of React-DOM renderer to mount into the DOM. So the React technically can exist without React DOM, but if you are rendering a browser app, you would need that React-DOM to project your app. Now the CSS part. You ask where index.css fits in this flow and whether it becomes part of JSX/React that create element. The key answer, CSS does not become React that create element calls. That CSS is a separate asset or module that the bundler handles differently. JSX transpilation is about turning this h1 element with the string hello into this React.create element with first argument string h1 comma null comma string hello. But CSS is not turned into React elements. So the transpilation, another thing is that it is about converting a seemingly look HTML or a seemingly HTML inside the JSX into a create React element with 3 arguments. So CSS is not turned into that kind of 3 part or create React element imported, or that CSS are not using the method create React element from React, or not being turned into these 3 kind properties and then later turned into a DOM, a call to a DOM API. So what happens to index.css then? In your main.jsx, you have import /index.css. That line is not a browser JavaScript behavior by itself. That is something your bundler/dev server like Vite understands. It means include this CSS file in the app build. So though because what's being compiled or transpiled in React is just the JavaScript. Now for the CSS part, it is also bundled, but the one responsible for bundling this is actually the bundler itself, not the React or not the browser. It's the bundler that or Vite that understands it. It means include the CSS file in the app build, which means this will be the styling of this node. Like you define the structure already and the logic, and this will be the styling of those structure and logic. So the bundler processes CSS separately from JSX. So again, the bundler separate the CSS from the JSX. So it bundled that differently, and those are not included in the same file. Now mental model, your app build usually produces something like JavaScript bundle, CSS asset, or injected CSS during dev. So here's what your app looks like: a bundled JavaScript file and a CSS asset bundled along with your JavaScript. Notice they are a separate file. They might be compiled at the same time, or they may be locked out for once compiled in runtime, so that others could not interfere, but they are in different files. So the browser ends up getting HTML, JS, CSS, not just JS. where your CSS fits in your flow. Your old flow was this, and then here's the complete version with CSS added. First, browser loads index.html. So this is the one where we will bootstrap the main.jsx and app.jsx. Second, browser parses HTML and creates initial DOM, includes div id equals to root, closing div. Third, browser sees script tag and starts loading JS bundle. So the browser will now see the script tag of that HTML and then now starts loading the bundled JavaScript. Notice that in this part, the JavaScript is already bundled. So because once the server sent that initial HTML, it needs to bundle that JavaScript first. Then fourth, browser may also load CSS asset or JS injects CSS in dev mode. So along with that JS bundle, it will also, or the server will also inject that CSS into that along with the JS bundle to style uh, uh, that DOM nodes that your app or React.js are asking to manipulate to the browser. Now, fib.js transmain.jsx, it will imports the app, imports index.css. So that's so those bundled now will now be what do you call this, kind of like a deserialization, because it will now be open up, or it will be went back to its previous original states, which is an in-memory structure for it to run in the browser or in the V8 engine. So in the browser, this will be the parent or the parent file that will spawn this child components, imports app, imports index.css, and bundler or runtime. Make sure CSS is available to the browser. So the bundler, your Vite, and the runtime, which is the V8 engine, are working together to make sure it's available to browser. Number 6, document that get element by ID with parameter string root returns real DOM node. 7, create root node creates React DOM root manager. So 6, we get the root where we will impose this already running in our V8 engine. So this is not running in the browser yet. Let me correct myself. So when you basically that bundle send those index and then bundle JavaScript, those bundled JavaScript will then now trace its path with the previous discussion. It will initiate those dots, and this track the path or the the dependency of those dots, and then it will initialize its values in the heap. Now after that, it will call the root, which returns real DOM node. And then 7th, it will use the create root. So this is the purpose of the create root we have discussed, which is the root node. So you can see now the sequence on how it actually works. Those will be put into the root node and then creates a React DOM root manager. So this root manager will now be the one responsible moving forward for updating the states that actually change. That's the diffing algorithm. Now 8, render app element receives the root React element. So the render here that we import the app, which already rendered here, will now receive this React root element. Then JSX has already been transpiled to JS, create element style calls. So this JSX now, once it's rendered, the app received the root element. Since JSX has already, JSX will now be transferred from heap to now create element style calls to the actual DOM APIs. Now React now executes the app function, then app returns React element objects in JS memory. So as you can see, once it called the DOM API, the React now will execute the app function, and then the app returns React element objects in JS memory. So the React will execute the app function. So that app function, of course, that inside the heap will determine how you would return the objects, whether there's an updated state or not. Now the app returns React element objects in JS memory. Then 12 React DOM converts those element description into real DOM nodes. So this is where the diffing algorithms run. Once React executes app, the app returns React element objects in JS memory, and then those app based on your code will only return the element that has been changed using like React React techniques such as hooks, state, etc. We will discuss that in the future. Now 12, React DOM converts those element description into real DOM nodes, and that's the time only the browser will change its nodes or the structure. And then 13, DOM nodes are inserted under root. And then browser now has DOM3. So as you can see, those element description are turned into 3, and those 3 are now inserted to or under the root that we have gotten in the step 6. Now browser now has DOM3 and CSS rules. 15, browser computes styles for each DOM node, matches selectors like root, body, root, h1. 16, browser performs layout, size, position, flexbox, width, margin, etc. 17, browser paints pixels to the screen. Then 18, user sees styles UI. That's the more complex X-ray. So important distinction, React creates DOM, CSS styles DOM. React is mainly responsible for creating or updating DOM nodes, setting attributes or properties, wiring events. CSS is responsible for colors, fonts, spacing, layout, visual representation. So React says make an h1, CSS says make that h1 56px and give it this color. Does index.css live inside the JS bundle? Depends on build mode. In development, tools like Vite often load CSS in a way that ends up being injected into the page, sometimes through JS-driven dev tooling. In production, the bundler often extracts CSS into a separate .css file that the browser loads. So, like what I've said earlier, when it's bundled from the server to the browser and sent to the browser, it's a different file because that's how you would load a web application before using HTML, CSS, and JavaScript. But in this case, again, HTML and JavaScript are already combined. So conceptually, your code import ./index.csx means this module depends on these styles. So this module depends on these styles, therefore you would only, or the browser would only show that to the screen once this once it apply or compute this style. But that does not mean the CSS becomes JSX or React elements. It just get included in the final app output. Another thing is that when we say that Vite often load CSS in a way that ends up being injected into the page, sometimes through JS-driven dev tooling, is that sometimes those CSS are in the development is using an actual JavaScript logic to import that into your development browser. So do CSS go into memory too? Yes, but in a different subsystem, not in like the heap or stack that we keep mentioning about the JavaScript and HTML objects. So the CSS go into memory too? Yes, but in a different subsystem, not as React element objects. The browser parses CSS into its own internal style data structures. So now the browser has two big things. First, DOM3, created from HTML plus React DOM. Second, CSSOM. So another way to describe HTML and JavaScript is the DOM3. So those are the data structure that we are keep mentioning that has heap and stack. Another is the CSSOM data structure or style rules. It is created from CSS files. Then the browser combines them during rendering. Then a simplified rendering pipeline is HTML or React DOM to DOM3, then CSS to style rules to CSSOM, then DOM to CSSOM to render tree to style layout. So as you can see, here we have React DOM and the HTML. It is converted to a DOM3. Then a CSS is combined to a style rules, converted to CSSOM, which is a tree, kind of like a tree as well, but it's for CS. Now we combine the DOM plus DOM3 plus CSSOM, render tree with styled layout. Now layout, after we have that, we have paint. So your CSS mainly affects step 15 onward in your flow. Example, using your CSS, you have root, width, max width, margin, text align, border, inline, min, high, display, flex, direction, box sizing. Now React DOM creates or inserts the real DOM node like this, id equals to root. Then browser CSS engine sees DOM node has id equals to root. Matching CSS rules exist for root. So browser computes style for that node, width, max width, display flex, etc. React did not perform those styles. The browser CSS engine did. Where root fits, you also have root with a text and then bg dot dot dot. Now root means the root element of the document, usually HTML. So browser applied those CSS custom properties there. Then rules like color and then background can read them later. Again, React doesn't interpret dash dash text of CSS. Browser CSS engine does. Super important separation. This is a plainest split. JSX or React side describes structure like this: div parent of an and then a child element h1 with a string hello. CSS side describe presentation. So h1 open semi-curly bracket key font dash size with the value 56 px semicolon then closing. So it's like an object of React when defining the presentation, an object of JavaScript rather. So React and CSS meet only through the real DOM. That shared meeting point is the DOM node. So JavaScript fundamentals before learning React. So when we want to learn JavaScript, React, we really want to learn more about JavaScript because JavaScript is not an easy language to learn. React is just a subset of it. So arrow functions in React. When teaching someone with about React, I explain JavaScript arrow functions pretty early. They are one of JavaScript language addition in ES6, which push JavaScript forward in functional programming. So um, these syntax are actually one of the reasons of JavaScript being pushed more of a functional programming as well as React. So we keep mentioning composition over inheritance. That's closely related to functional programming because with functional programming, we're mainly concerned about those small functions rather than creating objects for its function. So here for ES5, this is how we write function. Function get greeting empty parameter, then inside return welcome to JavaScript string. For JavaScript ES6 arrow function with body, instead of function, we use const greeting. We use const keyword and the function name get greeting, then equal sign, empty parenthesis, then arrow function, and then curly bracket as well, then return welcome to JavaScript semicolon. So this is JavaScript ES arrow function with body, and JavaScript ES arrow function without body and implicit return is this. Const, still const, get greeting, function, get greeting, which is function name, equal empty parenthesis, arrow function. Now this is without semi-curly bracket. So, and without return as well. Just the string, welcome to JavaScript string, semicolon. Now JavaScript arrow functions are often used in React applications for keeping the code concise and readable. I love them, teach them early, but always try to refactor my function from JavaScript ES5 to ES6 functions along the way. So if you have ES5 function, try to like convert that to a const, even if with body, with open semi-curly and then return statement, because it will make your code concise and you need to type less. At some point, when the difference between JavaScript ES5 functions and JavaScript ES6 functions become clear, I stick to the JavaScript ES6 way of doing it with arrow functions. However, I always see that too many different syntaxes can be overwhelming for React beginners. So I try to make the different characteristics of JavaScript functions clear before going all in using them in React. In the following section, you will see how JavaScript arrow functions are commonly used in React. So when learning React, to reduce a lot of cognitive load and to accelerate your progress early, you need to understand how to use this arrow function because this is enormously different from a normal programming language or from what a common sense programming language you have been taught of, such as function, parameters, open semi-curly bracket, and then body, and then return statement. Functions as components in React. React uses the best of different programming paradigms. That's only possible because JavaScript is many-sided programming language. On the object programming side, React's class components are a great way of leveraging the abilities of JavaScript classes, inheritance for the React component API, class methods, and class properties such as this.setState and this.state. On the other side, there are lots of concepts from functional programming used in React and its ecosystem too. For instance, so let's just continue with this in the next video. Functions as components in React, template literals in React, varlet, and cons in React.